Hi, everybody. I want to take just a few moments to talk about something that I haven't really talked about before. We've gone, we've gone over. So I had a set of slides on how to plot things with ggplot, and that was our first introduction really to R and to anything data science. It was very early on, and I asked you to do a plotting assignment, and I've also included a more extensive plotting assignment with the 538 assignment on recreating a graph. But what I haven't gone over, and I think is really important for data scientists, is not only how you should make a plot, but what kind of plot to make. So a lot of people, anyone with a little bit of training, can make a plot. But to make a good plot is actually quite a feat. So a good visualization can do a lot for you, and a bad visualization can do, well, nothing for you, even if you've done a lot of work on it. So that's sort of what I want to get into here. And this is, again, none of my material. There's a really good book that's free and online, but you can also buy it, called The Fundamentals of Data Visualization by Klaus Wilke, who is a professor at the University of Texas at Austin, or UT in Austin, Texas. So it's a really good book, sort of state-of-the-art book that came out a few years ago. A primer on making informative and compelling figures. So we're going to go through, I go through an outline of the book, really. The first part of the book has a directory of visualization. So the first thing that you should think of when you have data and you want to make a plot is, what type of plot can I visually make to actually address what I'm wondering or what I'm thinking or what I want to say to someone else. And so if I have categorical data, what type of plot can I make? Like, I can make a bar chart, I can make a pie chart, I can't make a histogram. So those types of questions, so like physically, what type of plot can I make? Then we get a little bit more nuanced with the principles of figure design. That's where we'll spend most of our time. And so those are like, what should I keep in mind when trying to create a plot? There are a few principles that he has in the book that we'll go over. And then there's a little bit extra at the end. So I have slides on here. The first, the directory of visualization. So the book provides a comprehensive overview of graphic types for almost any situation, along with principles of a good graphic. So first, it has the overview for the situations, then the principles of a good graphic. We're going to spend most of our time with those principles. But I do have slides here for every graphic. Okay, it would if we talked about it at length, it would take, well, one, because I like to talk, but two, there's a lot there. It would take us the whole semester. And then there is a handy directory that partially summarizes the graph types, and that's what I have on these slides. Okay, and so amounts, distributions, proportions, XY relationships, geospatial stuff, geospatial data, uncertainty, and so on and so forth, right? So there are lots of ones here. They all offer sort of something different, okay? I only have strong opinions about a few. We've already probably talked about a pie chart that, well, one, humans don't see well on angles. There are a few reasons that people generally don't like pie charts, or people in the stats community don't necessarily like pie charts. The only chart that I have a vendetta against on these, and you may not, are these error bars up at the top. Not the first error bars, but the bar chart with error bars on top. So these are often called, I believe, dynamite plots, and Excel, I think, makes them by default for some people. I see them around, and I can't for the life of me realize why people want to use them, because, well, there are a number of reasons that I won't get into here. But all in all, to say I hate that second error bars plot. And so don't use it if you ever do something for me. Okay? If you love them, I'm sorry, use them elsewhere, but don't use them for me. Anyway, now let's get to the principles of figure design. Okay, so these are the principles of a good graphic, and so the first principle is called the principle of proportional ink. Right, and what is it? What it means is the size of shaded areas in the visualization need to be proportional to the data values they represent. Okay, what does that look like? What's good? Well, what's a good one and what's a bad one? Well, let's see what a bad one is. Okay, so the top one is bad, and the bottom one is, well, good, I guess better. Okay, and so this discussion, I guess, loses a bit when I'm just talking to you through a video and we're not having a class discussion. But the first one up top, you'll notice you can pause the video of why it's bad, to think about why it's bad. Okay, so why the top one might be considered bad. It doesn't follow the principle of proportional ink. The y-axis starts at 50, ends at 70. This happens a lot. This is a very common example. You might do that, well, one, because the software that you're using might sort of do that by default. You may not even think about it. But you want to do that, especially if your people do that, because the y-axis might be huge. Now we're here up from median income can be as low as $0. It can't be negative, but the bottom can be 0, and it can go up. So 0 to 70,000 is a pretty big range. And so you might, and I would say it's logical to think, I want to only plot the sort of tops of the bars. I want to zoom in to the tops to really see the difference. Like, if you look at the bottom right plot versus the top left plot. So if you look at the two plots, in the top left, I think it's easier to see that Maui is better than the third one, which I won't attempt to pronounce. Okay, but if you look at the bottom right plot, that's a lot harder to see. So that's why people do it. Okay, you might do that in certain circumstances where the y-axis is just, I don't know, crazy large. But in general, it doesn't follow the principle of proportional ink. And what happens is that it overestimates, overshows the difference. So if you look at the top left plot, compare Hawaii's very small bar to Honolulu's huge bar. So, like, the proportion, you can fit, I don't know, 10 Hawaii bars in the Honolulu bar. So it looks like Honolulu's just blowing Hawaii out of the water. Which is, I don't know, 50-some thousand to 70-some thousand is a lot. But it's not showing, I guess, the whole story. Yeah. And so start bar charts at 0 if you want to follow the principle of proportional ink. Okay. So here's another reason or another example of some bad principle of proportional ink graphs, and then the good one up on the right. Okay, so bars tend to be troublesome, and so maybe you want to use something else other than bars. Okay, something nice, something good about pie charts are that they actually follow the principle of proportional ink if done correctly. Okay. Now the next issue, it's not a principle, it doesn't have a formal definition, but the second sort of principle of good graphics is this overplotting. How do you handle overplotting? And so if you look at this picture of fuel economy on the y-axis and engine displacement, sort of how big an engine is on the x-axis, so displacement versus MPG, and you color the points by drivetrain. So is it four-wheel drive? Is it front wheel or rear wheel drive? Okay, and so this plot may not seem so bad, but it is bad because under some of these points are a lot of points. So one point may represent only one car, but other points may be just one point on top of many of them and represent, I don't know, 20 cars. So one way to fix overplotting is partial transparency, or what's called alpha blending. And so I think I instructed you to do some alpha blending on a previous plot that you might have done. And so now if you look at points which are pretty transparent, they represent 1 point. Whereas if you look at some points that are still, I don't know, still as dark as can be, they have lots of points associated with them. So that can help. Another way to help is point jittering. So you add some random noise to each point. So you push it up, you push it to the right, push it, well, in any direction, in some direction, can be good. Now you can overdo it. So to the left is the good plot, where the points are slightly jittered. Okay? And so it still holds the overall shape of the graph, but you can see where a bulk of points lie. And then if you look at the right graph, they sort of overdone the jittering, and the direction of the plot, or the relationship, has changed. And so, of course, when you add random noise, you're sort of changing the data, which could be considered bad. If you overdo it, definitely is bad. But if you do it just a little bit, as long as you don't use those jittered points for any numerical summaries, you're probably okay. Okay. And then the last thing, I believe it's the last one, is too much color use. So colors are great. They're fun, and you may love to use them, but there is some point at which some color can be too much color. Okay? Or there is such a thing as too much color, which you may not agree with, but this is Klaus's opinion, so you may not agree with Klaus. So on the left, you have a plot of population size in 2000, and there's a different color for every single state, and that is, of course, a problem because, 50 states, there aren't 50 primary colors, and so when you get down to having to choose a color, there are really a lot of colors out there. But what you want to do as the creator of a plot is you want to make, of course, the colors really distinct. And when you have 50 states, and they don't include territories here, do they? Just the District of Columbia. So you have sort of 50 states and 50 colors. It's hard to distinguish. And so my point was, when you are the creator of a plot like this, you don't want the reader to have to squint and spend a lot of time trying to decipher what the plot means. You want the picture of what's happening in the plot to be very pronounced and very clear to see. So I want to be able to look at this and see whatever you're trying to show me very quickly, and not have to squint and try to decipher what's going on. And so that's the problem here, is that if you look at the color for North Dakota and then you look at the color for Texas, they're pretty close. They're both pink-ish, right? Or even like Alabama versus Alaska. Those two colors, really hard to distinguish. And so when you look at the plot up above, where's Alaska and where is Alabama? It's going to take you a long time to see that. And so if you're spending, a person's attention span is not very long, the average person. Okay? And so they're going to look at this plot and they're going to become, disgusted with it within 10 seconds. And they're going to move on and not understand what you're trying to tell them. Okay. On the right, we have a better plot. There are lots of states, too many for one state, one color, so make regions: west, south, midwest, northeast, and color or name the ones that you want that really say something. Okay? And so that's going to make your graph better, even though you are missing some states. So you've taken away some information. Okay? But you put the important ones on there for whatever you're trying to say with words, and you color them still so you can tell your story, but not overcolor. Okay. Here's another color use. It's fun, but does color really add anything in this case? And the answer is, of course, no. It's just there, to be colorful. And so if you want that, you can, but you're just not following Klaus's orders. Okay? And so, sorry, that's the end of these fundamentals of visualization slides. Hopefully they helped and made you think for a second about how I can create a good plot. There are many ways to create plots. Some of them are bad. Plots can be bad. Plots can be good. You want a plot which tells your story quickly without a lot of deciphering needed.